Today is the third in a series of 3 webinars on the topic of agent-based modeling for social scientists. Recordings of both of the previous webinars are already available on the UKDS YouTube channel, and a recording of this webinar will also soon be available on the same YouTube channel. So I'm just going to throw this table of contents at you real quick, and there's actually quite a lot to cover today, so I'll just get started right on it. Last time we had a couple of serious technical failures, so I thought it'd be nice to start off today by showing the model and how it runs. So I'll just click play here, and you can see all the little green arrows moving around, commuting, because that's pretty much all they can do in this model. But a bit of a description, this is a base house that have tram stops, and those tram stops are based on the actual agent stop. It also assumes that all trams go. There's a couple of new changes to the interface. Now I added these because I made a few changes to the model code. First, I want to point out that I added the CSV extension to make it easier to import and export information from CSV files. Also, just a few other details, like added some global features that are set during the setup process. For example, there's a global variable called tram stop connections. Later on in the code, you'll see this is where I store the contents of a CSV file that I open during the non-random setup procedure. This is what that file looks like. And every row begins with the name of a tram stop as it appears in the tram stop shapefile that I imported separately. You saw that in the last webinar. The rest of the rows contain all of the tram stops that are one stop away from the first stop on the list. For example, Abraham Moss is next to both Crumpsall and Queen's Road. Importantly, the rows do not have to be of equal length. There are only 2 stops connected to Abraham Moss, but there are 3 stops connected to Cornbrook. The way I wrote the code means that it doesn't matter how long each row is. I won't spend too much time on the code because I have put this code online so you can download the model and have a look if you like. However, I do want to briefly point out that setup trams command draws tram lines and tram stops directly onto the map from the shapefiles and saves the names of the tram stops as they appear in the shapefile. But then this part down here opens up the tram stop connections variable that holds the contents of the CSV file that we just saw. The model reads through line by line, finding each tram stop name as the first item in a row, and connects it to the tram stops that are in the rest of the row. So connects it to the tram stops that are 1 tram stop away. Agents cannot share more than 1 undirected link, so it doesn't matter if 2 stops each try to link to each other. The model won't allow duplicates. So now that we're familiar with our slightly modified tram commute model again, I want to talk about behavior space in NetLogo. This is where all of the actual experimentation happens, and I have no idea why they call it behavior space rather than experiment space. Under the tools menu, you will see behavior space, and this opens up a new little window in which you can set up experiments to run. You need to give the experiment, by clicking new, you set up a new experiment. Obviously we don't have any yet because, I'm showing you how to set them up. So you click new, and it opens up a window like this. You will have to set a name for the experiment. Try and be descriptive because otherwise you'll confuse yourself. And then you set all of the parameters that you can set. Actually, these already appear set to the way, however the model is set on the interface when you go to set up an experiment, but you can adjust it if you want to do other things. So you can set variables to have only 1 setting, like projection random, that it won't vary this parameter, it will just run the model in random. Or you can have 2, so tram commute only I had set both to true and false. That means it will run random models with true and random models with false for tram commute only. You can also do sweeps. So the number generated tram stops here starts at 20 and goes up to 100 in increments of 10. So that's how you do a parameter sweep. As we saw the behavior space has the capacity to report on model behavior. So we're zooming in on the lower part of that window here. Just want to make sure it's big enough that you can read it properly. And you can set commands where it says measure runs using these reporters. You can set commands like count the turtles or count the tram stops or count local authority agents with tram stops in their borders, whatever it is you want to do. You can do more than count, but I'm just keeping it simple for now. But you can only measure the runs with these commands at every step or at the end of the run. So this is a bit limiting depending on how you have your model set up. It doesn't really work for me, for example. I don't necessarily want to just count turtles. Sorry, this line needs to be adjusted. I want to be able to count things like how long agents take to get from one local authority to another, or how popular a particular tram stop is, things like that. That doesn't help if I only do it every step or at the end. So instead, I'll show you another procedure later for a more creative kind of output. But we also see here is the rest of the behavior space. So you then do setup commands and go commands. You can set a time limit. So if you only want it to run for 1,000 time steps or 10,000 time steps or whatever you want to do. And it's important to experiment on this random projection, for example. The first experiments will always be parameter sweeps, and they should use all of the parameters that you can vary. You should use very wide ranges, and you should use big increments and fewer repetitions. That means how many experiments, how many runs the model does at each unique combination of parameters. So, maybe only 10 if this is your first parameter sweep that you run. This is just to check and make sure that nothing weird happens, that you don't get any really bizarre results. Based on what you see happening, whether you do get bizarre results or weird unexplained things, you can run targeted parameter sweeps that maybe use some parameters but not all of them, use narrower ranges and smaller increments, and maybe some more repetitions. So for example, maybe in my first parameter sweep, I noticed that there is no discernible difference between tram commute only set to true and tram commute only set to false. I doubt that this would be true, but if my results showed that there was no difference between those, I would just pick one and go with it. I wouldn't continue to vary that as a parameter in future parameter sweeps. If you get through the second round of parameter sweeps, you would then go on to run actual experiments, which are many, many repetitions on a few settings, maybe only one setting, depending on how your model is set up. You might also go back and change your model code. So, maybe you might say, rather than a static network that commuters use to get back and forth over time, maybe you want a dynamic network. Maybe, if a tram stop is just too busy, you want to generate a new tram stop that's nearby and that's connected to other tram stops so that you can get some, so people can make choices about which tram stops they go through to get to their destination. Maybe you want that to happen when something like, a particular tram stop hits capacity too often, or maybe just at a fixed point in time. So after 1,000 time steps, you build a new tram stop and you run it, and then after another 1,000 time steps, you build a new tram stop. So, but that would require more model coding in the model. Mine is just a static network. These parameter sweeps and experiments are a way to verify the model logic and test the model sort of function and behavior and any changes you want to make. It's also to identify the interaction of parameters, so you'll know that you need at least 3 local authorities, but more if you have at least 50 tram stops or something like that. You'll find out which interactions are important and which kind of parameter ranges mesh well with other parameters. It also identifies breakpoints or critical ranges, so you know that things behave really predictably if you have less than 100 tram stops, but as soon as you start getting over 100 tram stops, things start getting a bit weird. You find that travel times really drop dramatically, or that the people start choosing strange routes to travel or something like that. That would indicate that there's a critical range at which behavior changes because of the parameter settings, and that's worth exploring. So this is a process of writing code and doing wide sweeps, which either tell you to write more code or do narrow sweeps, which tell you to either write more code or do experiments, which tell you to either publish or write more code. So it's a big, iterative, loopy, messy process, and I like it. So here's another experiment that you might want to set up, this time using the local authorities projection. Now it's important to note here, because a lot of the parameters that you could set will affect the random projection, but not the local authority projection. So the number of generated tram stops or the maximum random population, for example, doesn't affect the local authority projection at all. These values are instead drawn from the shapefiles. So you're going to end up with fewer experiments in total. But you still want to give it a good name. Make sure you change it so that it's not the same as the other name, otherwise you'll really confuse yourself. Set all the parameters the way that you want. So you still want to vary some parameters because some parameters will affect the local authority projection. Make sure you set a time limit. And this time, the first experiments will still be parameter sweeps. They're not quite as important to check the model function because we already did that thoroughly in the random projection. So you may not need as many rounds back and forth of iteration between sweeps and coding and sweeps and coding. So you'll probably end up at experiments sooner rather than later. You can still repeat individual sets of experiments on a large scale, or you can go back to the code and sort of change your code so that maybe your tram stops appear as they did in real historical sort of timelines. So, you know, you build so many stations on the first line and then you extend the lines and you build new lines. Well, those all have dates that you can add to the shape files, and you can make them come online when the model hits the right timeline for that. You could also add tram stops that don't exist in reality, but maybe you want to test what would happen if we built a tram line out to Stockport or Wigan. I mean, you still, in this case, the experiments are more about sort of testing your research questions and your hypotheses. They're still valuable for identifying breakpoints or critical ranges or interactions, especially as they're under a realistic layout rather than a sort of randomly generated layout. They're also good for comparing to real-world observations. Can we set up the model in such a way that people actually do take the amount of time to travel from one local authority to another as it does in the real world? That's an important sort of validation criteria. But they're also just about answering specific research questions. So, you know, if we built a tram line out to Stockport, how much less time would people need to get across the city? Things like that. So we've set up these two experiments, and you can see that the first one has lots of runs, of over 500,000 runs, because there's so many parameters, and you can set them up to sweep and vary in so many ways, and each one is run 10 times because we set 10 repetitions. So a lot of runs. Whereas the local authority one, the second one, has 40 runs, and there's just fewer parameters to vary, so there's fewer runs. But you still need to actually hit the run button if you want to run the experiments. Before we get to that, I want to talk to you a little bit about output. Really good output is well motivated by your research design. You know, the kinds of things you think you want to measure in the real world should be also measurable in the simulated world, so that you can really say something about what's likely to happen or what the problem might be in the real world. Also the model design, so, you know, do you output to a CSV file? Is it a number? Is it a string? These kinds of things. And the sweep, rewriting, sweeping kind of stages, that kind of iterative development will help you know if you need commas or quotes or, you know, what column things should be named, things like that. Just really basic stuff. This model does not have amazing output because it didn't have really well thought out research questions. Nevertheless, without making any changes, I could still ask some questions like how long does it take to travel between one local authority and another on average? How many trips are taken between one local authority and another or within the same local authority? And with quite easily, I could change the code to give more output like how popular are different tram stops or how often do people go to different destinations. So this would just be to ask those agents to report on how many commuter agents are located at that point at that time. So if we do hit run, we get a little window that opens up that gives us a spreadsheet output, a table output, update view, update plots and monitors. Spreadsheet and table output are the same, but one is narrow and one is wide, and I'll show you in a minute. Update view and update plots and monitors, they mean that the simulation runs on the screen, the same as when you're running it through the interface. But you don't need these. You can set it to run quietly in the background. It will run faster and use less computer power, and that is more environmentally friendly, so please consider it. So then you hit OK, and you get a little window like this that's telling you what experiment you're running and what's going on, you know, how much time has elapsed, which run of how many, what step are you at, all of these things. You can also have the option to click the update view or update plots and monitors if you want to snoop on what's going on. But again, that uses a lot of power, so yeah, consider not. So this is the spreadsheet view. This is the automatic output that I got if I just told it to count tram stops at the end of a run. Just wanted to show you a little bit what these behavior space standard outputs look like. So it starts off at the top with some details about when the model was run and some features, some global features, and then the parameter settings for this particular run, and then the actual values that it records according to the outputs that you set. This is the same information, but in the wide table format instead, just to show you if you care strongly about whether it's wider or narrow. Alternatively, I would like to say that the output built into the behavior space can be more sophisticated than I've shown you here, but the choice to measure selected commands at every step or at the end of the run and the table and spreadsheet options, they're a little bit limited, and you can probably do better by building output options directly into your model code. Now, that is not actually as scary as you might think because we imported the CSV extension earlier, as you will remember, I'm sure, paying attention thoroughly. Specifically, this not only lets me import the CSV file that tells tram stops which tram stops they're connected to, but it also allows me to export CSV information very easily. For example, initial exports here is now a part of my setup procedure, and what it does is it creates a file that is uniquely named for the run that is relevant, and then it prints a header line in that file. So it prints, you know, it just gives headers to 6 different items that I thought might be interesting to export. And then whenever an agent arrives at its destination, it opens up that file and writes a line in that file saying who's doing the reporting, where this journey that they've just finished started, both specifically the place they started and the local authority that they started in, where it ended, both specific and the local authority, and how long it took. The clever-eyed among you will notice there's a typo in there, but I won't highlight it any further. So this process will give you one CSV file per run. And if you're running 500,000 runs, that's a whole lot of CSV files, but CSV files are pretty easy to work with. This is what one looked like. And if you want to open it in Excel, that's what it looks like. So if you open it in RStudio, which is not particularly difficult because CSV files are pretty easy to read into R, I will make these R this R script available as well if anyone is interested. It really isn't very interesting, but you can have it if you want. So you load up the CSV file that's exported from NetLogo into R and have a look at it. So again, this looks just like it did in Excel, but this time it's in R and therefore better. You'll notice that house and place, because the model exported them as agents, they're wrapped in parentheses. That's not ideal. Parentheses are kind of a special character in R, so we should probably get rid of that. Also, I'm not really sure that we need to know the exact house that the journey started from or the exact place that it started from. Probably it would be more useful to know if someone is starting a journey from home or from not home rather than exactly which house. So we can do a little bit of editing in R. And I won't go too much into this because maybe you already have lots of experience with R and you'll look at this and go, well, that could be done a lot more concisely. Or you'll think, I don't use R. I don't want to sit here while she uses a lot of R at me. There's a lot of other ways you could go about doing this. So I'll just show you a couple of examples of the steps that I took in R. So I loaded up the file. I did a substitution to remove the parentheses. And I did a separation to split the origin column into journey and specifics. Now journey will have house or place, and specifics will have the who number of the house agent or the place agent. And then I actually only need some of the columns because it occurred to me that I don't need the specifics at all, and I don't actually need the destination specifics at all. I'm happy with the origin local authority and the destination local authority. And then I rename my columns just to make it a little more interpretable. Again, there's a typo. If you can spot it, well done. I don't apologize. So you've opened up a file, cleaned it up a little bit, and now you're ready to do some analysis. Now some shockingly basic analysis is just to count how many journeys began in one local authority and ended in another, including within the same local authority. So this just gives you a very brief way of looking at the data to say which kinds of, are within local authority journeys more popular, what are the most popular start and ends, that kind of thing. Slightly more interesting analysis is to create a heat map based on the time it takes to get from one local authority to another. So again, I like R because this is only a couple of lines of code and it gives you a nice shiny heat map. Now you see the intersections, so within local authority journeys, are quite short comparatively. They take much less time than between local authority journeys. Weirdly, Salford to Oldham takes longer than Oldham to Salford. I have no idea why. And that's the kind of thing that basic, fairly boring parameter sweep experiments can tell you. So maybe that's just a quirk of this particular run, but if I had done this run 100 times and averaged out the analysis over the 100, and this pattern still persisted, then that would definitely be something I would want to look at. What's going on there? Why should that be? Does it match reality? I'd have to call people in Salford and find out. The summary is that we revisited the Tram commute model, and I will make it accessible to you if you want to download it. I think I put the links on the end of this slide, so you'll see them in just a moment. You can play around with it, you can change the colors, you can add more stops, whatever you like. I've showed you the behavior space, which should be renamed experimentation space, but we will leave it at that because I'm not in charge. But you do need to think, to effectively use the behavior space, you do need to think about your experiments. So you want to do parameter sweeps first and then targeted parameter sweeps or even targeted research questions like how much time will people save getting between, Salford and Oldham if we build a new line or, something like that. Or if we make a new connection between stops that already exist. I highly recommend building output creation directly into your model code. It is an optional extra because Behaviour Space does have built-in output options. I just don't find them very sophisticated. I find them to need a little bit more creativity and thinking about how to make them work. And I find that because they always start off with the information about the model run, when it was run, and what the parameters were, it's a little bit, it just needs a little bit of cleanup. Whereas you can create those rows in a column, a separate column, or even a separate document. And that way you can keep all that information handy, but not have it in the same file as your actual results. Showed you how to open output, how to process it a little bit, analyze it in a couple of fairly trivial ways. I'm sure you could find more interesting things to do quite easily. How to visualize it. I mean, the heat map was pretty cool, but, you know, could have been better. Brighter colors anyway. And then here's my code. That's quite a large link. So I made a tiny URL. And hopefully that will mean that you can, if you're interested, download the model, have a play around, ask me some specific questions like why did I make the typos that I did, as you like. All right, we are at the stage where you get to ask me questions. How can I find the program you used in the webinars? All right, that's no problem. NetLogo is available from Northwestern University. You can just put NetLogo, N-E-T-L-O-G-O, download in any search engine, and it should direct you to Northwestern University's page. It is free to download. It is quite a small file, so it should download quite quickly, and it is available on all major platforms. If you specifically want my model code, here's the link again. You can, I recommend the tiny URL because it is much easier to write. This means that you can be directed to, it's a website called OpenABM, where people, researchers who have created an agent-based model can lodge their code, also sometimes their results or their data outputs or publications that have been, you know, written up using the model code, anything like that. And you can really sort of, you can browse through, there's hundreds, maybe even thousands of them on there. You can see ones about, you know, shopping behavior or community interactions, language exchange, all kinds of very interesting models. Also some things like flooding risk, you know, there's a lot of interesting stuff. Some use maps the way I did, and others use sort of generic simulated landscapes, and you know, they address all kinds of different topics, but you can find lots. When I said APIs, did I mean application programming interface? Yes, I did. You better believe it. Yeah, we are planning on having another 3-part webinar series coming up, probably starting at the end of March, if all goes to plan, or early April, on what are APIs, how do you use them, and sort of some demonstrations of different kind of research questions that you could address in interesting ways by using APIs.